So still on the topic of improving like the latency, optimizing the latency of your system, you have to make sure you have as low latency as possible. Don't forget, I say latency is the time it takes from one system to talk to another system over a communication network. So you want to reduce as much as possible. We've looked at some factors that might cause it. You've optimized the database, you've optimized your queries, you've used the CDN. But since some things still seem to be slow, and one of the things that could cause it could also be the system load, right? So your system is actually doing a lot of work. And you might have experienced this even in your own personal life, your day-to-day, in which you have so much work you are doing that you can't actually keep up with doing some other activities, and it just seems like you're very slow. So how do you improve this? Some of the things you can do is to actually either horizontally scale your system or vertically scale it. So by vertically scaling, you're adding more CPUs, more RAM, improving the performance, the processor of your system. And by horizontally scaling, you're adding more machines and putting everything behind the load balancer. So the load balancer is taking another request. Usually the load balancer is probably a very high performance system on its own. So you can take a lot of requests and process it. And you have a whole host of servers behind the scene and just sending the request to each of them and getting a response from them. So you'd have designed the architecture in a way that even though you have multiple servers or multiple instances of your application running, everything still works perfectly. Right, so that's one approach you can use for this. Another approach you can really do is by dividing your applications into in microservice architecture, right? Depending on your particular context or use case, such that the systems that require a lot of complex loads, complex compute, are on the isolated application-wise, code-wise from your core application, so that these systems don't slow down your application. So, for example, you need to process video. You don't want to be running the video processing logic on the same application that fetches the user details or the user list or the user account lists or the user's landing page, because people are more forgiving when their video takes a while to process, but they're not as forgiving when the core of the application doesn't work. So you can isolate that to a different system, and that system can be optimized uniquely or separately from the core application logic. There are many ways to do it. So you design an application in microservice, you run two different instances, use Lambda functions, use ECS, just to keep things separate, right? So like this, you can mitigate some of the problems that would come with your system actually performing under heavy loads and this affecting your latency. So a request comes in, the system processes very fast, and it goes out. So yeah, this is a very short one. Let's explore the last approach. If you want me to talk about another thing, I can talk about it in another video. Finally, one other thing that could contribute to your system having a very high latency is that you are implementing a protocol, a secure protocol. And this, maybe not high latency, but the protocol you implement actually contributes to the latency of your system. But on a very low level, something as simple as using HTTPS instead of HTTP increases the latency of your system. Not by much, so you should not be worried. And you should definitely use HTTPS because the benefit outweighs what latency adds. But think of it this way, right? If you're using HTTPS, your front end has to make a request to the backend, first of all, to establish an handshake to verify the security credentials and all the drama that goes on there. Then when the request comes back, it now actually makes a proper request to actually fetch the record or the request it needs. So the security protocol you implement could contribute to that. That shouldn't be much of a problem usually. The difference is not that much. Another thing that really matters is the size of the content you are dealing with. So now you're dealing with content that are very large. It takes time for it to be processed and actually sent over to you. So you can use things like gzip, compression at the load balancer layer to actually compress the file so that your browser would uncompress it back. And it obviously takes shorter to transfer a smaller file than it takes to transfer a larger file, basically. So you compress the file to a format that the browser understands. When the file gets to the front end, it uncompresses it and speed can be improved. Yeah, so this has been a very interesting one, exploring the different ways you can improve latency. There are a lot of other ways this can be done. If anyone comes to mind, I'll just drop it in the comments or update the article attached to this. But let me know in the comments what you think, if there are better ways you can do this. And don't forget to like and subscribe so that you get notified whenever I add new videos. Thank you. Peace out.